so this is abusing software-defined networks. So yeah, here we go.
Thank you. I'll try to get this right. It's very loud this year. Okay. You used to have to pretty much hold your face right in the mic. Okay. Thank you, first of all, for coming out to talk today. As you said, this is abusing software-defined networks. My name is Gregory Pickett with HELLFIRE Security. You know, you have to do a plug. A brief overview of today's talk. What is it? What is software-defined networking? Right. And then some weaknesses in software-defined networking and how to exploit them. Right. And no matter how much fun it is in breaking things, we are here also to help. So we'll also tell you how to fix it. And then moving forward, obviously we need to protect it. Protect it now as well as for the future. It is going to be a big part of what we do with the network. And then wrapping up, I will be introducing a toolkit today to explore SDN, these particular controllers, as well as in your own environment. Right, so I will show you where to find that, as well as provide some links to learn more about software-defined networking. We will start with, well, networks as they stand today. They are very vendor dependent. You learn a unique set of skills. You learn the commands for that for a particular piece of hardware that a vendor sells. There are unique features to those pieces of equipment we buy, those switches, the routers, that we become dependent upon. All right, now these networks are difficult to scale. We're adding one box after the other, right, each with its own configuration. Therefore, the network becomes rather complex, rather fast, and prone to break. Right? The configuration is distributed, and there's often an inconsistency because each box has its own unique view of that network. We make mistakes, all sorts of things happen. And they use protocols that, well, we are not responsible for these protocols. They were developed, turned into a standard, and we have to use them as they are, regardless of how well they work for us. And the network is also unable to consider other factors, right, like application needs, business needs. You can't see anything outside the bits and bytes of the flows. Right? And good luck. Once you have all of this set up, it's rather brittle. Good luck if you actually want to try to change it. Okay. Enter software-defined networking. Right? The idea is to separate the control and the data plane. Right? The forwarding decisions are made by the controller. You take the logic off of those switches and routers, you put it into a central controller, and then the switches and routers just forward packets. At the controller with the logic, it's programmed with the intelligence. It has full visibility of the network and can consider the totality of the network before making any decisions to enforce a very granular policy, right? A very granular and consistent policy across that entire network. This leaves the switches as bare metal only. Right? Any vendor, hardware or software, really doesn't matter. They are truly a commodity. Right? This solves lots of problems. Right? With commodity switches, right, the hardware then is very, very inexpensive, less expensive, right? So it reduces the cost of operating a network, solves a lot of problems that we have with BGP, you know, items and aspects of BGP that are lacking. Right? A lot of neat things you can do. You could do a maintenance tryout. You don't have to just take a router out of service, wait for the routes to recalculate and propagate. You can just steer the traffic around that router ahead of time before you do your maintenance. You give your customers, you can give your customers the opportunity to choose where on the network their packets egress. You get better security at the routing level with BGP because you can consider other factors such as reputation, right, before selecting your next hop. Faster convergence. You don't have to wait for events to occur, nodes to detect it, propagation of routes. You can just go ahead and tell everyone this is now your next hop. And it also allows for granular peering at the internet exchange points. You don't have to be in a situation of all or nothing. You can decide what sorts of protocols you're going to peer over, right? What protocols you're going to use to communicate with your neighbors. Right? And it expands our capability. Right? We can do real-world network slicing of the flow space. We can take that VLAN idea and expand that network wide. We also are able to can expand from server load balancing to network load balancing, gaining a significant amount of efficiency in the network. And security, there's so many different things you could do with security under SDN. A very dynamic access control. You can apply your access control that includes a lot more than just this host can talk to this host over these protocols, over these ports. You can then begin to say, okay, times of day. You can add a lot more dimension to it. Adaptive traffic monitoring, you no longer have to have fixed points on the network that you are looking at. You can move your traffic monitoring around as the needs, as needs change. And it also allows you to program the network with a bit of intelligence so that the network can begin detecting attacks and engaging in mitigation automatically. So a lot of really neat things that you can do with SDN. Okay. Now there are some emerging standards that they have come up with. Well, not really come up with it. They realize, after a certain point that the network gets a little unwieldy, a little out of control, and we've kind of known this for a while. They attempted to adapt existing protocols to kind of gain the breadth of control as well as the consistency that SDN provides. Right? Before, I think even SDN was an idea. All right, so they had SNMP, extensions on BGP, netconf, Lisp, PSEP, but there was always something lacking. So they went ahead and designed a protocol from the ground up, right, OpenFlow, with kind of a sister protocol, OBSDB, to implement SDN from the ground up, considering all the different factors that might be involved in it, to start over. And that's what we will be talking about today, OpenFlow. Right? It establishes elements, and establishes that paradigm, the controller making all the decisions, a secure channel for the controller to talk to the different forwarding elements over, right? And defines a forwarding process at those forwarding elements and messaging format to then communicate information back from the forwarding elements to the controllers. Okay? The forwarding process. The forwarding element will check the flow table. If a match is found, it will carry out the action. This is very much like a firewall. If no match is found, then it sends the packet to the controller. The controller makes its decision, referencing policy, and then updates the flow table on that forwarding element. The forwarding element has a flow table. It's basically a set of match action entries. There are 12 fields available for matching. And there's wildcard matching available too, so you can pretty much kill more than one bird with a single stone. You don't have to have a single entry for each type of packet that you might end up running across. Graphical representation of that relationship. Controller communicating with in this case, an OpenFlow switch with its flow table over the secure channel using the OpenFlow protocol. So this is the paradigm we'll be looking at today, what these people have tried to make happen in their products. All right, so we have some proprietary controllers. There's lots of actually controllers out there, but these are some of the leading platforms. Cisco has some, HP, IBM, and of course open source, Knox, Pox, Ryu, and the ones we'll look at today, Floodlight and OpenDaylight. Specifically because, well, they're production capable. They are promoted as something you want to put in your network to run your operations. So we need to know what we're in for. Okay? Floodlight is an open source Java controller. It's primarily an OpenFlow based controller supporting version 1.0. It's a fork from the Beacon Java OpenFlow controller maintained by Big Switch Network. So one outfit is behind this. OpenDaylight is an open source Java controller. Many southbound options including OpenFlow. There's a lot of backward compatibility there with the other protocols. Supporting 1.0 and 1.3. It's also a fork from the Beacon Java OpenFlow controller. Linux Foundation collaborative project though, right? A lot of guys, a lot of companies with their hands in it. Citrix, Red Hat, Ericsson, Hewlett Packard, the rest there. Right? A lot of industry heavyweights. Okay. So, all right, we have some problems. OpenFlow, we've had this idea for SDN. OpenFlow is going to do it for us. It's going to solve those problems. It's going to be nothing but puppy dogs and rainbows, right? Yeah. That's what they always tell us when they're trying to sell it to you. Not exactly. Not exactly. That's why we're here. Okay. So there are some protocol weaknesses. And we'll start with the protocol, less serious to the more serious things. Encryption and authentication is specified. It's implemented using TLS. But it's more of a suggestion than a requirement. It started out very good. 1.0 was saying, okay, yeah, TLS. Got to do TLS. 1.4 said, yeah, we don't have to do TLS. You don't have to do TLS. You can do TCP if you want. And as you know, when you give someone the opportunity to be less secure, to slack, if you will, they will do so. And we'll see some slackers here. So Floodlight said, we're not going to do it then. You don't require it, we're not going to do it. So no support. OpenDaylight, all right. OpenDaylight's a tad better than Floodlight. It supports it, but it's not required. Right? And the switches vendors, kind of a mixed bag, but you're really in the same boat, right? Arista no, Dell no, Stream yes. There's a couple yeses in here, but a lot of no. So along with some more no's here. So you really have a situation where even if you want to do TLS, based on the makeup of your controller and your switches, you may not be able to. So a large portion of people wanting to even try to do this won't be able to. And what we found with these implementations is that they kind of left a few things out. Encryption, yes, of course, it's TLS. But going through all the configuration options, you really don't see anything in there for certificates. Allow certificates, you can't do authentication. That means pretty much anyone in their dog, to use an overused phrase, can talk to this and manipulate it, attack it, kind of like what I've done. It's mixed bag here. So the large portion of people don't even have an option because you don't have a matching of controllers and switches. And even if you do get it, it's kind of a half coverage there. You're really still exposed there. Okay? Now, what this could lead to, right, for a vast majority of people using these products and using the protocol, right, information disclosure through interception and modification through man in the middle. Right? That's a large portion of the people trying to do OpenFlow, try to do SDN, because they don't have the right match of equipment. Now everyone though is going to be or have an issue with denial of service, because even if you are one of the lucky ones that happens to have a controller using TLS and a switch that chooses TLS, I mean, you can't change. Once you have your switches in place, you can't, it's not easy to change over, you're stuck with it. Right? But let's say you are lucky, you have a switch that supports it, and you've got a controller that supports it. It really doesn't matter. All right, no authentication, so pretty much everyone across the board is going to have issues with denial of service. Okay. So speaking of denial of service nastiness, right, OpenFlow, it's about centralization. Centralization, well, it's dependency. Dependency can be exploited, so we have to look at how the vendors are handling it. Well, Salomon, Francis and Eton looked at it, looked at Floodlight. Did some experiments. They set up a Floodlight controller. They brought up some instances of CBench, and what they found was that Floodlight handles it poorly. Okay. It even, there's some actually options, and when you compile it, to put in some rate limiting, right, to turn on rate limiting. And they found that when you turned on the rate limiting, it was actually worse. Okay. Now they have a presentation on this. It's on SlideShare. I recommend you look at it and see what they came up with, what they're able to do, how much it really took, how many instances of CBench it took to actually take this thing down. It wasn't very hard though. Okay, so now there's also OpenDaylight. It is unknown. I didn't take a stab at this, but it's worth investigating because it is Java, for God's sake. All right, memory issues. Right. Now, you too can either recreate Salomon et al.'s work or play with your own controller, poke at it. All right. Started off looking at SDN, in particular OpenFlow, and I built kind of an emulator here, OF switch. Right. This is the beginning of the toolkit. It impersonates an OpenFlow switch utilizing 1.0. It exchanges the hellos. It will receive a feature request. It will return the features. It will receive a set configuration. Respond to that. It will receive a get configuration. Does the whole thing. Send a bogus configuration back, and then do echo request, echo reply over OpenFlow with that controller. So you can observe that yourself, see how these things interrelate. Flood takes that a little bit further. It establishes that relationship, and then just pounds on it. Pound to pound, pound. There are 12 fields, right, available for matching. You just do the math, the number of possible combinations. One instance of Flood hitting that controller with all those millions of packets. You throw up a couple more, and let's see how many it takes to knock over the controller of your choice. Okay? So a little fun you can have there. Okay. Now, it's important to note, so we have the TLS issue, right? TLS issue, not really implementing it really well, those who are that part of the standard. As they move along and get to that, and they begin to completely get through the standard and become more compliant, debug ports will be a problem. Okay? There's no encryption, no authentication, just full control of the switches. This is a switch side issue. All right? You can use a very, very easily attainable tool, DPCTL. Right? So as I said, they are still working out, getting TLS in there. So it's not a problem yet, but once they get past that and become more compliant, get to the debug port, start looking for those in your environment. Are the debug ports showing up on our switches? So it's not a problem yet, but soon will be. Okay. Now this is where we get to the fun stuff. Okay. Controller weaknesses. This gets bad here. Floodlight. No encryption, no authentication on the Northbound API. You can just connect to it, take control of it, and have your way with it. Right? Not a problem. It's a very easy controller. Right? OpenDaylight. There is encryption for the Northbound API, but they were kind enough to have it turned off by default. Thank you very much. Well, I work a lot in offensive security, so for me it's a blessing. I like those things. And there is some authentication for that Northbound API, but it's HTTP basic authentication. Right? Not much of a challenge. Default weak password and strong passwords turned off. Another thank you. Now you may say to yourself, with OpenDaylight we have a little coverage. Not really. Okay, there are weak protections there, but we can actually get around those. I have an exploit for you today. It's brand new. Right? Have a 0 day. It's going to allow you to bypass all that. Right? So while they're there, they won't be a problem for you. Okay? Now what this means is both controllers, right, either directly with Floodlight or indirectly with OpenDaylight using an exploit. All right, they're going to have problems with information disclosure through interception, right, topology, credentials, right? If they don't turn on the encryption on the OpenDaylight, you can get the credentials. Information disclosure through unauthorized access, right? Topology and targets directly with Floodlight, indirectly with OpenDaylight, right, using the exploit. Then turn around and do the same thing, right? And there's problems here with topology, flow, and message modification through unauthorized access. While you're there, you might as well add access, remove access, hide traffic, put blind spots in those sensors, and change traffic. Right? Flow rules are rather flexible. You can change things, add VLANs, take VLANs away. Right? So directly with Floodlight or indirectly with OpenDaylight. Still, both of these have these problems. Okay? Now, first off, you have to identify controllers and switches. You can't have fun with them if you don't know where they're at. Okay? Now, they're currently listening on TCP port 6633, but there's now an official port of 6653. Okay? All of the tools allow you to change the port. So if you run across a next gen or the version 2 of any of these things and they change the port, or they're trying to be secret and they hide the port by moving it to something else, you can go ahead and adapt, add a port as a command line argument and still use the tools. Right? Now to identify these guys, you try to exchange hellos, right, with a service to see if you're working with an OpenFlow based service. And then if you get a feature request back, then you know you're dealing with a controller. Right? So that's what we do here with the next two tools, OFCheck and OFEnum. These two are about discovery. So you're going to be giving them kind of lists of targets, and they're going to narrow things down for you. Start out with your bigger list, OFCheck. It identifies OpenFlow services and reports on their versions. Let's say you have 100, you give 2 or more if you're going to the, class C. So you give that big list to, I don't recommend necessarily scanning the internet, but they're out there. I'll just say that. All right, so you have a list of, let's say, 100, and you go ahead and you go through that with OFCheck. You'll take that smaller list and it'll hand it off to enum. Then it'll enumerate the endpoints there. It'll tell you whether or not you're working with a controller or a switch, because, of course, you want the controllers. They're the fun ones. Okay. All right, now, for those who don't play around with Python too much, there is also an Nmap script to add that capability to Nmap. Right? Same functionality as OFEnum. Enumerates OpenFlow endpoints, reports on their type, right, whether it's a controller or a switch. So let's go ahead and identify some right now. Is that big enough? Yeah. Okay. So we have OFCheck. Say we have a target list. All right. OpenFlow service version 1 found at 192.168.267. I kind of knew it was there, but all right. So we got that there, and then you would go ahead and take that smaller list and pass it off to enum. Bigger. I think the next size is way too big. So it's right up here. All right, so we have OpenFlow controller found at 192.168.267. So very easy to identify these guys. No Nmap script today. Okay. So once you've identified it, you can go about some naughtiness. We have a small local area network there. I've instantiated it in Mininet. It's a great experimentation tool. 1 admin host, 2 user hosts, 1 server, and a sensor which I will call an IDS. Right? So the attacker, me, that's the fun stuff, so I'm going to do it here. Identify targets, enumerate ACLs, and of course look around to see if anyone is listening, looking at what may be going on. Okay. We'll do that with OFMap. It downloads flows from an OpenFlow controller and then uses those flows to identify targets and target services, identify ACLs, right, and to identify sensors. It works with Floodlight and OpenDaylight via JSON. Right? It auto detects the controller you're working with. Now I did mention that there were credentials with OpenDaylight. Okay? The exploit actually allows you to get the credentials for OpenDaylight. It will start off, if it auto detects a OpenDaylight controller, it will use the default for you. Okay? That's very nice of it. If you must go get the credentials with the exploit, you can then plug them in, right? OFMap and the next one, OFAccess, will allow you to add credentials. Should they change it and you have to go get it, you can put them in there and then go ahead and hit the OpenDaylight controller anyway. Okay. And we'll demonstrate. Okay, here we go. I have to learn how to spell. And we know the controller. 192.168.267. There we go. All right, so the first thing we want to do is map that network. Okay, let's get a report on that. There. All right, map the network, then of course the connection. It would normally show you the switch you're attached to. That's a bonus, actually, because you want to know if you're going to make some flow modifications related to you, you kind of want to know where you're at. Right? For some reason, on these networks here, I'm not seeing that. Have to figure out why. Next thing you might want to do is look at the flows. But in a production network, I don't necessarily recommend you do that, at least not live on the screen. You can if you want. Number 2, it lists all the flows. The option in a production network is to do number 7, which is dump the flows to a file. All right. Since, well, we can go ahead and take a look real quick. I don't know if it'll fit here. All right. It does not fit at all. All right. So we'll go ahead and just jump to the good stuff here, which is list targets. Okay. So 225, 215, 227, 228, and a number of ones here. This happens to be me, 215, server 225, and admin at 228. Next thing I'm going to look at here is list ACLs. I want to know what I'm being kept out of because that's actually exactly where I want to go. Oh, wrong one. That should have been it. Oh, it's just very big. Okay. All right, so 215 is me. I'm being kept out of 225. As I said, that's where I'm not allowed to go. That's the first place I want to go. So there we go. Isn't that where all the fun stuff's at, right? Behind locked doors? All right, so we have the ACLs then. I want to check to see if there are any sensors. All right, this does it by dissecting or looking through the flow tables to see if there's any mirroring. So number 6, identify sensors. Right. All right, so there's some mirroring going on to port 5. I'm going to select this because I need this later on. So very easy to dump the flows, identify targets, and then find anything that might be looking at you, watching what's going on. Okay. All right, well, we're not going to stop there, right? We always start off an attack with reconnaissance, but the next thing is our vulnerable identification, exploitation, that sort of thing. So as an attacker, I'm going to open the way for myself and take that same network. I'm going to grant myself access to that server, and then I'm going to isolate the administrator. Turnabout's fair play, right? I don't want him interfering. And then I'm going to put a blind spot on that sensor. I'm going to remove that mirroring for myself and my target. And it leaves me free to then attack the server. The tool we'll be using is OFAccess, or I'll be using. Modifies flows on the network through the OpenFlow controller. Adds or removes access for the hosts. Right? Applies transformation. You can actually write your own flow rule and put it in right from the tool. It also removes mirroring for any particular IP of interest, yourself, or I'm going to do that, of course, and the target. Right? It works with Floodlight and OpenDaylight as well via JSON, auto detects everything. Put credentials in if you need to for the OpenDaylight controller. Okay. And demonstration. So we're going to go over here and run this OF access. Now, the first thing I want to go after is that server, but then I have to grant myself access. So let's show how I can't talk to the server now. Right. Nothing up my sleeves. Okay. So I currently can't talk to that server. Request timed out. Now I'm going to go ahead and through the magic of SDN and in this case Floodlight, it's easiest to go after. I will grant myself access. 92168. And that's why I need the switch. I need to know what switch to put the flow rule on. And priority. Priority is a little tricky. All right? Right now the tools only overwrite entries. So it's important to have a high priority. Right? With Floodlight, overwriting requires the highest priority. So I'm going to accept the default here. Right? Next version, yes, I know it's always that way. Next version, I will be adding a feature to remove flow rules. So I'll accept that and then confirm. It's very polite. And then ping that server. Okay? There we go. We're not finished yet. We got to go after that administrator. All right, so we have H4 is administrator, ping H1, ping the server. You currently can ping the server. We'll let that go. And then I'm going to take that away. So drop traffic. 192.168.2.2.2.8 is the administrator. And 225 is the server. Same switch. Same priority. Yes. And now, denied. There we go. We'll break that off there. We're seeing lots of drops there. 42% packet loss right off. But there's still some mirroring going on there. I want to take care of that. So I'll move that up there. Let's go ahead and hide from sensor. I'm going to go ahead and hide anything heading toward me. Don't mirror that. And the same switch. And we know it's on port 5. Not quite yet. I want to show you something here. We're going to do TCP dump. We'll see how it does currently see me. No tricks here. Some pings. All right, so we're seeing both sides of that conversation currently being mirrored to the sensor. Now let's put a blind spot in. I need to go over. And so anything heading toward me will not be mirrored. And then let's do this other side of that, the server. I actually did the wrong one here. All right, let's go. All right, hide sensor. There we go. So that's 225. Yes, yes. On that same switch. Stop any mirroring to port 5 for anything heading toward that server. Ooh, lost. Yes, you have to excuse my Windows 8. Get out of here. What's that? Thank you. And back to this way. This was a last minute replacement. I haven't yanked all that stuff off. All right, so that was hidden. Now let's go ahead and start this up again. There we are. Pinging, of course, going through, and let's go, all right, 0 packets captured. Thank you. Nice little blind spot, so, which is what I like. So now you can do whatever you want. Have your way with that server, if you will. And not only will nothing see you, but no one can stop you. Okay. Now, okay. So I talked about OpenDaylight. It's a little indirect, right? So there's a small problem with OpenDaylight. A little bit of a problem. So I found that, and we're going to go ahead and exploit that weakness. Exploit OpenDaylight. So sorry, Linux Foundation. No puppy dogs and rainbows for you. All right. All right, so this is awfully detailed, probably more detailed than it should be. All right, so OpenDaylight, they're very backwards compatible. And there's other southbound APIs besides OpenFlow. No encryption, no authentication on this. It's a TCP version of netconf. Just connect and exchange messages. Can you see where I'm going with this here? Okay. XML RPC. What's hot today, right? What's hot? XXE, right? External Entity Injection. Well, Java. All right, if you're familiar with XXE, Java has a big problem. All right, you got all sorts of space out there dedicated to that. OWASP pretty much paints the door right on this, and here's go in. All right, Java, big problems with XXE. So, boom goes OpenDaylight. And this is the bonus. This is the bonus here. It runs as root. Yes, that's what I said. Okay, demonstration. So, let's go ahead and exit out of here. Let's just do this. I tweaked out a little bit, added features. Got one at 60. All right, there you go. Okay. Now it starts out with the default of the password file, but I'm greedy. So I'm going to go after the shadow file. I mean, you've got the access, you might as well use it. Okay. It's very friendly, it says hello. Everything's okay. There we go. We're feeling all right. All right, that's the latest one. There we go. Thank you. I mean, that's the good stuff, right? Hashes. So then you can mount an offline password attack, gain the system credentials. You're going to get a lot more on that box than Northbound API credentials. But I mean, after you're done with that box, you might as well go after everything else. So hey. Right. So you get those credentials and you plug them into the tool, and then I'll show you just here a second here. All right, it's important to note before I go through the whole thing, the whole cycle again with OpenDaylight, or show you how, what you can do there. If the service is not available, all right, let's say you don't have the opportunity to use the exploit because the service is not available, or lo and behold, they fix it, it's not to worry. You can password guess it, okay? Default password's weak, strong passwords turned off by default, no account lockout, and no syslog output. So you can just pound on it, and pound on it, and pound on it, and get the credentials that way. All right? So either way, you just repeat. All right? Go through the whole cycle again, and then own that network too. All right? So OpenDaylight, you put those extra protections in place, didn't turn out to be much. Okay? Other exploits are waiting to be found. This is where you guys come in. All right? The only way to get these people to secure this stuff is just keep poking at it, right? Northbound APIs, Floodlight, southbound APIs for Floodlight as well. OpenDaylight has the northbound APIs, OpenFlow, southbound APIs. The netconf, there's also an SSH1 debug port for netconf. And this is the other services also running on the box. Okay? Lots of these are XML based, being run by Java. Right? I see some duplication here. Duplication. So go out there, poke at the sucker, You know, you're going to find stuff. You are. Available solutions. Yes, this is the less exciting part. For now and for the future, of course. For right now, transport layer security. All right, we were talking about it, but it's not really finished. They're not really done with it. All right. For those of you not supporting it, put it in. And when you do put it in, add authentication, please. Do certificates. All right. Those who currently have it, throw that extra piece on. We need to close the loop on this. All right. I'm not sure how good at TLS is in this situation that you're using certificates. All right. Now, as we move to commodity switches, it then also becomes realistic. Right? You're going to be able to spare up some cycles for TLS. That's probably a lot of the reason why vendors aren't implementing it. It takes extra cycles to do TLS. Right? Going to commodity switches, you have the cycles. Right? So it's very feasible and very realistic. Make it happen. Hardening, of course. Right? These are some of the basic things that we should be doing anyway. And then, of course, VLAN. Right? Too many flat networks out there. Too many flat networks out there. I'm a network guy. All right? But even I know you need to do a code review. Right? As I said, OS pretty much paints the door on the outside of this box and says, here, this is how you get in. All right? I can't imagine they did a code review. Please go back and do a code review. Those vendors out there, if you haven't done a code review, we haven't looked at it yet, do one before we get there, please. Okay. Now for the future, this is a little bit more in the details of SDN. To protect against denial of service, right, you have to consider your SDN architecture. Partition that network. Don't put one controller or a group of controllers in charge of the whole network. Not a great idea, especially as the network gets larger. Performance, it also comes into consideration. Because not just denial of service, but also in the performance of the daily operations of the network. And then controller clustering. Spread the burden out a bit. All right? Share the load. And then when you can, put in static flow entries. Right? A lot of this is going to occur because you've got reactive mode where the switch is going to go ahead for every single packet it sees, it's going to send up. Right? It doesn't have anything to go with at the beginning. So it's going to send every single packet, it's a lot of combinations, right? Millions, up to the controller. If you have some static flow entries that you can use them so it doesn't necessarily have to depend on the controller as much, it doesn't need to depend on it as much as possible, right? So minimize that. And then, of course, to protect against modification. This is about the SDN applications. Traffic counters are available. You don't have to infer the network. You can actually measure the network. You can see it as it's currently operating. The application space within the SDN controller is really supposed to be about putting in these codes, right, code sets, modules that put on these boxes that are supposed to do a lot of that work. The APIs are kind of secondary external integration. So as these go on here, you can throw on secondary applications that are all about security, right? Reading in the traffic counters, measuring them, looking for abnormalities, and then responding. All right, so have those applications in there that kind of check what's going on. Now that's kind of after things are in operation. You can do things on the front side too with verification, with header space analysis, where you turn the switches and the routers into a mathematical model, and then you basically punch, all of your packets through that, and you can actually see how the network is going to operate beforehand. So the verification is the front side where we can verify how our policy is going to function, and then you have something on the back side with the secondary applications to kind of monitor things and respond. Right, when abnormalities show up. So you can get coverage there to protect against people like me poking around. Okay. Now, how prevalent is this going to be? We see issues, right? We see these weaknesses that are easily exploitable. But if they're just a couple people, yeah, we have a couple people that may have to worry about it, but what about the rest of us? Well, Gartner says, the academics say this is going to be one of the 10 critical IT trends for the next 5 years. Right? So they are looking into their crystal ball, and they're seeing this having a really big impact on the enterprises out there. Major networking vendors, right, have products planned for SDN. Right? They're betting money on this. And people are already moving on it. All right, 60% felt that SDN would be part of their network within 5 years. Okay? 43% already have plans to put it in production. Okay? It's actually here now. Okay. Data centers in the cloud space, Nippon Express, Fidelity Investments, VMware. Right? In fact, this is considered the killer app for it. And the expectation is actually higher in the cloud space, 80%. 80%. And then, of course, we're seeing it in the LAN with Caltech and CERN, and the WAN as well, already here. Right? Google has it on one of their major backbones. NTT and AT&T, everyone is rushing forward into this. So this is something that we are all going to have to keep an eye on. This is something we're all going to have to worry about. Right? It's not just isolated to these controllers in these unique situations. It's all of us. We're going to have to address this. Now, assuming we move forward on this, that we are going to move forward on this, how could it go right? What are the things we expect to see at the end of this besides, the problems that it solves? Vendor independence and ultimately lower cost. Right? A lot of the limitations we currently experience in network space will go away. Right? Networks that match the application and the business needs and not the other way around. We don't have to make our network fit the equipment. We can make the equipment fit what we want to do on our network. And a faster evolution of that network. We can actually run production scale simulation side by side, and we do lots of experimentation. Allows us to do things like we'll exchange network aspects, right? Instantiate network function virtualization, where we actually have middle boxes, we have load balancers, we have firewalls, and we can actually move those things around wherever they need to be, right? As traffic conditions change, so the situation changes, right? And then you get dynamic and truly active defenses. You can program that network to detect abnormalities, respond to those abnormalities, and start defending itself. So a lot of amazing things. Right? But a lot of bad things could also happen too. Okay? Denial of service. It's like a dog pile. All the nodes on the network gang up on one other node. Right? You think bots are bad. Wait till you harness an entire network and you just slam somebody else. Right? So that's bad. Flip side of that, selectively dropping traffic. A message disappears, right? An important message. A transaction never arrives, right? Man in the middle. Let's say you want to do be a little more creative, right? A little more ninja. Man in the middle of an entire network. Local subnets hosts, right? Change a transaction amount. Change maybe an email a little bit. Piss some people off. Start manipulating events. It gets bad. Shadow operations, dark nets. Network within networks. You get Uber admins. Moving the chess pieces behind the scenes, right? This could go bad if we aren't keeping our eye on the ball. Okay? Right? So we need to make the difference. Right? This is what this is about. Traditional means of securing controllers still apply. Right? Now, security, it has been part of the discussion. I said it needs to be, but it needs to be done in a different way. Until now, it's been about, they're all very excited about how it can help security, but people aren't really looking at how secure SDN is. Right? Analysis are being done, but typically being done by outsiders. Right? And people are doing it in a very traditional approach, or a very 2D approach, right? Very isolated. The code guys, the application guys looking at it separately from the network guys. They need to kind of converge there. Because controllers really, they need a security reference. They need a security reference and an audit capability. They talk about these as a network operating system. So start treating it like one. Right? Make sure that operations are authorized. Make sure that once operations occur, that someone can figure out who did it, what they did, and when. Right? All right, now some final thoughts. We're wrapping up here. SDN has the potential to turn the entire internet into a cloud. Right? The benefit would be orders of magnitude above what we see now. But there's a hole in the middle that could be filled by the likes of the NSA, right? Nation states like China, but we pick on China, but they're all doing it. The United States, Russia, the Euro bloc, governments are getting in the middle there. We don't want them there, all right? Let's not let that happen, and that starts here by telling you guys about this. So we start poking holes, we start holding these vendors to account, right? These developers. Okay. The toolkit, as we wrap up here, all right? It's available at sdn-toolkit.sourceforge.net. I'm a little old school, right? The hash there. Make sure it's genuine. And some links, get that mouse back, to provide some context to today's talk, get more information. I highly recommend a course taught on Coursera by Nick Feamster, Professor Feamster, SDN, nuts and bolts from beginning to end, learning about SDN. All right, so that's it. Thanks for coming.